Dear students, today we will discuss about a freezing curve. It's an important portion. So let us know what is freezing curve. It is a temperature at the thermal center of a food. When heat is removed, it can be given by a characteristic curve as temperature versus time. That curve is known as freezing curve, which is shown in the figure. That is temperature time graph. There are mainly three phases for the freezing curve. From A to B, then C to E, then F to G. A to B is the section 1, C to D is the phase transfer stage, that is section 2, and F to G is the phase transfer tempering period, that is section 3. So we can move to or we can divide the graph into three: pre-cooling, phase transfer stage, and tempering period. These are the three stages in freezing process. So first process is pre-cooling, that is removal of sensible heat to lower the temperature of food to the freezing point. So theta F is the freezing temperature or freezing point. Then next stage is phase transfer stage, that is removal of latent heat of fusion, that is leading to change of state and formation of ice crystals. That is, the water will be changed to ice crystals. That is phase transfer stage. And last one is tempering period, that is after the formation of majority of ice crystals, further sensible heat removal which is down to the required storage temperature. So theta A is the temperature of the freezing medium, or what is that, our storage medium temperature. So mainly there are three major phases or three stages of freezing curve: pre-cooling, phase transfer stage, and tempering period. So this is the freezing curve. Now we will study by different section or different parts of the freezing curve. That is from section A to B, B to C, C to D, D to E, then E to F, and last F to G. So we are going to study different sections by section wise. So let's move on to first section, that is section A to B. Here the food is cooled below the freezing point, less than 0 degrees Celsius. That's why the point B is at below the theta F, that is below the freezing point. And at the point B, the water remains liquid although the temperature is below freezing point, that is not without forming the ice crystal. This phenomenon is called the supercooling. So supercooling is an important process happening inside the freezing process. Because of the supercooling, we will get the good texture. So maximum up to 10 degrees Celsius below the freezing point, the ice crystals will not form, but water remains as water itself, since the temperature is below freezing point also. And is in this period the nucleation starts. So supercooling is the going below freezing point but without the formation of ice crystal, so without any crystallization. It yields better quality food than if there is no supercooling. Next come to the stage BC, that is from the point A it goes down to point B. From point A it goes down to freezing temperature, then again less than 10 degrees Celsius, that is minus 10 degrees Celsius, up to, that is point B, supercooling occurs. Then B to C there is a rise in temperature. So temperature rises rapidly to the freezing point, giving off the latent heat of fusion. Then from this point the ice crystals is begin to form, the latent heat of crystallization is released. So this is the important portion, that is after supercooling there will be the formation of ice crystals, that is crystallization. So ice crystal forming or crystallization. The initial freezing point of a food is the temperature at which a minute crystal of ice exists in equilibrium with the surrounding water. So water is both intracellular and extracellular. So there will be difference in concentration of solutes and all. So ice crystals is begin to form from that point. So there are mainly two parts for the ice crystal formations, or that is crystallization, that is nucleation and crystal growth. First one is nucleation, that is site for crystal growth or crystal formation of growth. That is, first there should be a site. First there should be a nuclei. On that the growth will happen. For that part is known as nucleation. That is association of molecules into a tiny ordered particles sufficient to survive and serve as a site for crystal growth. There are two types of nucleation: homogeneous and heterogeneous. Homogeneous means chance of orientation and combination of water molecules, and heterogeneous means there will be surrounded particles or at the cell wall that more likely to occur in the foods. So there will be different types of nucleus. That's why it is known as homogeneous and heterogeneous. Then the temperature is known as nucleation temperature, where the first ice crystals appear in a solution. That is also referred to as supercooling point or crystallization temperature. Next stage is crystal growth. There is an enlargement of nucleus by the orderly addition of molecules. So first one molecule or first one nuclei is formed at the nucleation, and onto that nuclei different types of nucleus is added. Orderly addition of the molecules, and this crystal is growing. The crystal growth can occur at temperatures just below the melting point, while nucleation starts at the lower temperature, that is supercooling. Then heat transfer is more responsible for limiting the rate of crystallization due to the large amount of latent heat needed. So crystal growth can occur at the temperature just below the melting point, while nucleation means at the supercooling point. So this is the important section, that is ice crystal formation. There are nucleation and crystal growth. Nucleation simply the site for crystal growth of crystal formation and growth, and crystal growth is the enlargement by the orderly addition of molecules. Next stage is a CD. So first sensibility is removed. Next section is we have to remove the latent heat. So we already studied when the latent heat is removed or phase transfer stage, phase is transferred from water to ice crystals, so it is liquid to solid, the temperature will be constant. But here, you see the temperature is somewhat changing. That is, from C to D, there is a slight decrease in the temperature. Then what will be the reason? The freezing point is gradually depressed by the increase in solute concentration in unfrozen liquor, and that's why the temperature is fall. That is, heat is removed as latent heat, so the temperature should be constant. But here major part of ice is formed, and in the unfrozen liquid there is some water which is not frozen. In that water there is an increase in solute concentration. That's why the temperature fall is happening here at slightly. Okay, then once stable nuclei are formed, they continue to grow, and it is during this stage that the major part of ice is formed from the C to D. So first stage is pre-cooling, next stage is phase transfer stage. At this stage, the crystallization is happening or continues. Majority of the crystals is formed during this stage C. Next stage is stage D to E. That is, here one of the solute becomes supersaturated and crystallizes out. Then latent heat of crystallization is released, and the temperature rises to a different temperature, that is eutectic point or eutectic temperature for that solute. Eutectic temperature means the temperature at which crystal of an individual solute exerts in equilibrium with unfrozen solute and ice. That is first ice crystal is formed. That ice crystal and other water particle or other individual solutes and all, that equilibrium stage. At that equilibrium stage, the temperature is known as eutectic temperature. It's different for different products. Mainly for glucose it is -5 degrees Celsius. For sucrose it is -14 degrees Celsius. For ice cream it is up to -55 degrees Celsius. In case of meat it is varied from -50 to -60 degrees Celsius. So this temperature also important, eutectic temperature, the temperature where there is no further concentration of solutes due to freezing, the solution is getting freezing. So maximum ice crystal formation is not possible until this temperature is reached. So this temperature is also very important. Next stage is stage E to F. That is crystallization of water and solute continues, and the total time TF, that is freezing time taken, is determined by the rate at which heat is removed. How the heat is removed. Based on that rate, we will we will find out the temperature of freezing. Sorry, time of freezing, total time. Coming to the end of the freezing curve, that is F2G. If freezing continued below this commercial temperature, ice formation and solute concentration continue until no more water can be frozen. So it remains the ultimate and it reaches. So the temperature of ice water mixture falls to the temperature of the freezer temperature or atmosphere temperature. That is the surrounding temperature, not atmosphere temperature, where the food is keeping. So the temperature at point G is known as glass transition temperature of the amorphous concentrated solution. So all the sensible heat and latent heat is removed when a crystal solute, that is depends concentration, is reached. The physical state of the unfrozen liquid changes from a viscoelastic liquid to a brittle amorphous solid glass. That is got the ice. That is freezing is almost completed. There is a final stage, that is tempering period. So thank you all. I hope all are clear. It is a very important portion, that is freezing curve from A to B, then B to C, like that. That all stages have to be noted. Pre-cooling, phase transfer stage, tempering period, and the important points are supercooling, then nucleation, crystal growth, then eutectic temperature, and why is the temperature falls slightly while the phase transfer change happens and all. Hope you understood. In next section we will discuss about the different equipments of freezing or different types of freezers, then about the Planck's equation, that is the calculation of freezing time and all. Hope all are safe and fine. Thank you.